All right. Let's understand what are ORMs one more time. Let's understand Prisma. Let's create a simple Prisma application. And then in the end, focus on relationships and how you can create a simple to-do application with the relationships in Prisma. This is something we did not cover very well during our live video, which is why I'm going to spend a lot of time here. I'm first going to recap everything from 1 to 9 so that you have some idea of the original class on Prisma. Let's get right into it. The first thing we discussed in our class was what are ORMs? And the easier to digest definition for this was ORMs let you easily interact with your database without worrying too much about the underlying syntax. SQL language, for example. Basically, an ORM makes it very easy for you to talk to your database from your Express application. So if this is your Express app or whatever Node.js runtime or Node.js backend that you're running, if you want to interact with your database, you can, let's say you were using MongoDB as the database, then you can use Mongoose as the library. If you are using Postgres as the database, then you can use PG as the library. But if you use the PG library, if you remember from yesterday, you had to understand the SQL syntax. You had to understand how you can write queries like these, which is very hard as a developer. These queries get more and more complicated. And wouldn't it be nice if you could write simple functions to talk to your database rather than, writing these complicated SQL queries? That is what an ORM provides you. An ORM lets you easily interact with your database without worrying too much about the underlying syntax. Let's see what benefits it provides. The first benefit is the ease of writing code. Without an ORM, if you are using the PG library to talk to a Postgres database, this is how you would write code if you remember from our last video. You have to first understand what an SQL query is. You have to understand the syntax of SQL. You have to write this query and pass in the arguments. Wouldn't it be nice if you are able to simply write something like this? User.find email and the email that you're trying to find. This syntax very clearly is much simpler to write compared to this. That's the first benefit of using an ORM. Second benefit is, specifically Prisma lets you very easily flip between databases, which basically means if this is your Node.js application, your Node.js application code will remain the same irrespective of what database you are using. As you can see, this has no real concept of an SQL query or a NoSQL query. This is a simple function call. And irrespective of what database you are using, you can write the same function call. Prisma will take care of converting this Prisma call either into a MongoDB call or into an SQL query that will finally hit the database. So it makes it very database agnostic, at least as the application developer. As the person who's writing the backend code, you don't have to worry at all about whether you're using a MongoDB database or you're using a Postgres database or you're using an SQL database. The third thing is type safety. If you are not using an ORM, then you don't necessarily a lot of times get good types. What do I mean by good types? I mean, if I do a client.query and give it like a select query with some arguments, the result that I get back has an any type, which means it's not annotated well कि हाँ, the result will have an email field, a first name field, so on and so forth. Comparatively, an ORM gives you very nice types for the things that have been returned. If you ever do a user.find and give it whatever arguments you want, the final thing that you get doesn't just have the value, it also has very nice types associated with it. For example, it knows that the user that is being returned has an email, has a password, has a username. You can use these specific things to get autocomplete in your VS Code, which you will not get here if you're using a PG-like library. So what do ORMs provide you? They provide you type safety as you use the functions that the ORM provides you. If you do a userdb.find, the value that you get back has not just the value, but also an associated type that you can use throughout your application. And lastly, one more thing it provides you is something called automatic migrations, which basically is if you have an SQL database, you have to maintain the schema of that database, right? If this is my SQL database, which let's say has a table called the users table, you have to keep updating the schema. You have to keep telling the database that the structure of this thing looks something like this. It has first name, which is a string, and last name, which is a string, and age, which is a number. You have to keep updating the database and keep telling the database, okay, this is the schema of my table. There is no easy way to track all of this schema in a single place. That is what a migration is. A migration represents telling your database, okay, this is what the users table looks like. Let's say currently your database resides in AWS. So you have your AWS database, you have your AWS console inside which you have created a database where you have done all of your migrations. Now let's say AWS goes down. AWS is like, we are not supporting databases anymore. Please move somewhere else. And so you create a fresh new GCP, Google Cloud Server. And here you create a new database. Now, when you've created a new database in Google Cloud, you need to tell it, right? Okay, the users table looks something like this. You need to perform a migration and tell the newly created database, okay, this is what the users table looks like. There is no easy way to track all of these migrations. There is no single file that you can create very easily, which has your schema as your application grows. But Prisma provides you that. Prisma provides you automatic migrations. It gives you a file that you can just use. And as you change your databases, you have a file that has, all of your create table queries, alter table queries. As your application grew, as your schema changed, you have all of these stored in a single place. We will see this very soon. That's the fourth benefit of using an ORM like Prisma. Quickly to recap. Number one, simpler syntax, very ugly to write, very simple to write. Number two, makes it very easy for you to flip between databases at the application level. You don't have to worry about what database you are using. Number three, type safety. Whatever values you get whenever you do a user.find or user.insert, whatever value you get has an associated type. So it makes it very easy inside Visual Studio Code or generally inside TypeScript for you to write your project, because everything has an associated type, and you can, if you're making a mistake while you're writing your code, the TypeScript compiler will be able to complain. And lastly, automatic migrations, which basically means it maintains a very long file for you like this that you can just apply to a new database whenever you are moving from one database to another. Those are the four benefits. Let's look at the official definition. The official definition of Prisma says, Prisma unlocks a new level of developer experience when working with databases thanks to its intuitive data model, automatic migrations, type safety, and auto completion. So these are the four things that it provides you. Data model is a single place where you can write what your database looks like, the shape of your data. Automatic migrations is a very long file that it creates for you, which has all your create table queries, your alter table queries. Type safety and auto completion is gives you types throughout your application. So as you're writing code, you can get auto completion in Visual Studio Code or whatever IDE you are using. Cool. That's what the four things over here mean. Next up, let's understand how you can install Prisma in a fresh application. So let me open this on the left, and on the right, I will create a empty project where we'll be doing all of this. Cool. I would urge you to open the same thing in Visual Studio Code so you can code along with me. Let me structure it slightly better. So Visual Studio Code on the right, which currently is completely empty. Terminal here at the bottom, and then the things that we have to do here on the left. The first command is to initialize an empty JavaScript project or Node.js project. The thing to do is npm init-y, which what does it do? It creates an empty package.json file for me. Number two, installing all the dependencies. In our case, the dependencies include Prisma. That's it. Surprisingly. So it does not use Express currently, which means we are creating like a very simple application. We're not creating an HTTP server. Of course, in the real world, when you're creating a backend application, it will have Express as a dependency. Right now, we just have Prisma. Everything else is like Not really needed, but I've added it. Prisma is the only dependency we've added, which means we're probably creating a very simple application. Initialize TypeScript, npx tsc-init. Once you run this, you should have a empty tsconfig.json. If you open it, change the root dir to /source, change the out dir to /dist. And that's it. You have the very basic version of a Node.js application. Doesn't even have Prisma yet. If you look at the folder structure, let me create an empty folder here called src. Let me create a file here called index.ts. But nothing fancy here. A simple Node.js application, only it has Prisma as one of the dependencies right now, but nothing else. Cool. Once you've done this, and make sure you do this locally as well, is when you run the first command that actually initializes Prisma. What do I mean when I say initializes Prisma? It actually tells the Node.js project कि हाँ भाई, we are using Prisma as our ORM, and you can start to use Prisma to do a user.find or a to-do.find, so on and so forth. So the first command to run is npx prisma init. This is something you will always run only once when you're bootstrapping your project, when you're starting your project. And what does this one line of code do? The most important thing it does is creates a prisma/schema.prisma file. I repeat, what happened when I ran this command? Let's see what the logs say. It says your Prisma schema was created at prisma/schema.prisma. You can now open it in your favorite editor. Let me open it in my favorite editor. There you go. And it has a bunch of code here. Let's see what else it says. It says set the database URL in the .env to point to your existing database. If your database has no tables, then read this. We are creating a fresh application. Our database has no tables, so we will not worry about reading through this. Set the provider of the data source block in schema.prisma to match your database. What is the database we're using today? We are using Postgres, which is the default value here anyways. If I was using MongoDB, I would have had to replace this with MongoDB. And then ignore the command it asks you to run, ignore the command it asks you to run. So the first two things it has asked us to do is, number one, replace the provider with whatever provider you want. In our case, we want Postgres, so we will leave it as is. And number two, it says, replace this with your Postgres database URL, your connection URL. I can replace it directly over here, or it gave you a hint. It said, create a top level .env file. Create a file at the top called .env, which it already had created, and replace your Postgres credentials over here. So if you by this point have either a NeonDB database or have Postgres running locally, replace this URL in .env with your connection string URL. If you look at schema.prisma, it is picking up database URL from your env file. That's what env of database URL means, which means in this .env file is where I have to replace my Postgres URL. Now you can get a Postgres database from NeonDB, you can get it from Avian, or you can start it locally. I am going to start it locally, and the video 12.3 in our dashboard very in-depth sort of shares how you can start Postgres locally using Docker. I'm going to use the same commands to run it locally. So the command number one is, let me delete all the Docker images I have running locally. I don't have Docker, so let me quickly fix that. All right, I finally have Docker running locally. If I run Docker PS, it shows me I have no containers running locally, which means I can just start Postgres now. So Docker run, might have this here, there you go. Docker run -e Postgres password equal to whatever password you want to give to your Postgres database that you're running locally. I'm just choosing my super secret password -d, which means run it in detached mode, add the port mapping, and then the name of the image on Docker, which in my case is Postgres. How do I find this name? Just search for Postgres Docker image. Whatever you find on hub.docker.com is what the image name is. We have covered all of this in 12.3 that you can find on app.redxdevs.com. If I run this, it now has Postgres running for me locally. If I run Docker PS, it shows me I have one container running. How do I create the connection URL for this? If you remember, it looks something like this. The username is Postgres. The password is what? The password is this my super secret password, whatever I passed in as the Postgres password environment variable. And then localhost is the host name, and 5432 is the port at which it is running. The database name is Postgres again. This is my connection connection string. For you, if you're starting it locally and if you started it using this command, it will be the same. If you are not starting it locally, if you started it on NeonDB, if you found a paid service where you got a database from, you will find this connection URL over there. We have covered all of this in all through this video. So we'll go through a few videos on SQL in week 12 and you'll be able to understand how you can either start it locally or get it from somewhere else. Let me remove all the comments from the .env file. So this is what my .env file looks now. This file that I have at the top. And what does prisma/schema.prisma look like? It has URL as a database URL environment variable. Cool. That's all that was expected from this slide. For you to at least initialize Prisma, for you to at least create this top level file where you have defined now कि हाँ भाई, we are going to use Postgres as our database. As I showed you a few slides ago, Prisma lets you connect to anything. Mongo, Postgres, this should be SQL. So you don't necessarily have, you're not necessarily restricted to a single type of database, but in our case, we are just using Postgres, which is why I wrote Postgres over here. The URL I'm getting from the top level .env file and not, hard coding it over here. The reason you shouldn't hard code it over here is because this file finally goes to GitHub and you don't want your secret database URL to go to GitHub, which is why you put it in .env, which is something that you usually don't push to GitHub whenever you're pushing your code. All right. This is enough for you to bootstrap the application. Now let's write some application level code. Selecting your database, we've already done that. We're using PostgreSQL. Adding Prisma as an extension if you want to, see all of these colors. So if you don't have the Prisma extension, which I do, and I would urge you to install it as well. Once you install this Prisma extension is when you will see very nice color coding in this schema.prisma file. So you can add it if need be, if not, that's fine as well. Defining your data model. Now comes the most interesting bit of defining the data model, defining the shape of your data. Let's say you're creating a very simple application which lets a user put in to-dos. Okay, so very basic to-do application. You have to define the schema for it. You have to define what should the database look like. Harkirat, I remember this. We used to write commands like this: create table user with, all of this fields and then text and then varchar and then number. I remember this from SQL. Yes, that was true for SQL. This is not SQL. This is Prisma. Prisma can be used to create NoSQL databases. It can be used to create SQL databases, which is why you don't have to write SQL syntax here. You have to write syntax that looks like this. So here you have to learn a little bit of how Prisma expects you to give it the data model. And it's pretty simple. It says whatever tables you want finally, give them to me like this: model, user. Model basically represents what entity you want in your final application, what tables in the most simplest fashion you want in your final application, which in our case, we're going to have a users table and a to-dos table. So this is how you can define the first table. And then comes what all fields do we need. We need an ID, which can be an integer, can be a string as well. Let's stick with integers. And here it says at ID at default auto increment. Does this look familiar a little bit? If I take you through the slides of SQL, do you remember the create table query? What was ID there? It was serial and primary key. It said, okay, bhai, I want this to increase by 1, 2, 3, 4, 5, 6, 7. And this is the primary key of this table. That is exactly what at default auto increment and at ID means. At ID means ke this is the primary key for this table. At default auto increment means serial. I want this to go up by 1. This is how you define your schema in Prisma. This is how we defined it in Postgres. In the end, you will see this actually gets converted into this only, but we'll get to that very soon. Next up, let's say you need a username. I mean, you can just copy all of this from here. Everything else is pretty straightforward. We have a username which is a string and is unique. Password, no need for it to be unique. First name and last name. You can also make them optional like this. I think, could be wrong. Pretty sure this is right. If you add a question mark at the end, it means first name can be optional, last name can be optional. Depends on your use case whether or not you want to enforce a user to give you first name and last name. Let me just put a question mark over here. And that's it. This is for the users table. Can you now yourself write the code for the to-dos table? Looks pretty straightforward, right? Can you try to write this? Let me stop Copilot over here. It's helping me a lot. Would urge you to stop it as well if you're doing it. Disable, there we go. And now let me try to write it. Model, what will it be? It'll be a to-do model. I still see Copilot. I probably need to stop it, but hey, let me not look at the suggestions and try to write it myself. It'll have an ID, which will be it'll be the same thing as above. Integer, I'm just going to use Copilot. ID default auto increment. What all other fields do I need? Title, description, done, and user ID. Title, description, done, I'm assuming is pretty straightforward. Title, which will be a string. Description, which will be a string. And lastly, done, which will be whether or not this to-do has been marked as done, which will be a Boolean, which is false by default. Why does this help? This helps because whenever you're creating a to-do, then you don't necessarily have to specify done. It will by default be set as false. You can also specify it if you want, and then just have your query put in false by default. Last thing it has is user ID. Can you now guess why we need user ID over here? It is so we can relate both of these tables. So we know that this to-do is for which user, which is why we need a user ID over here as well. It can be user ID, it can be user ID, whatever you want. And a good question to ask at this point is, Harkirat, in SQL, we created foreign queries. We created foreign keys. If you remember, when we were defining relationships in SQL, I told you the concept of foreign keys. I said, if you define the users table, you define the addresses table, you can define them normally. But this extra line you have to add if you want to relate addresses to users. If you want to tell that every address needs to have an entry for a user. We have not done that here yet. We will see that later on. We will see how you can add relationships in Prisma. But right now we have written it very raw. We have said a users model, a to-dos model, no relationship between them yet. I mean, you can see a relationship. You can see there's a user ID here, which represents which users to-do it is. But we haven't dictated this foreign key rule yet. We will add it eventually. But right now, this code will convert to this SQL to create a table and create a table minus this foreign key constraint, because I haven't yet added the foreign key constraint over here. Cool. Let's see what do you have to do next. Let's see if this is enough for you to start to create tables in your database. What is the next command that you have to run anytime you change schema.prisma? What has happened? Anytime you change schema.prisma, you need to regenerate these queries, right? The create table queries or the alter table queries. So you have to run a command to generate those migrations. I repeat, anytime you update schema.prisma, anytime you add a new field here, update a field here, add a new model, you need to run a command that will actually give you these create table queries. For that, the command is this: npx prisma migrate dev and the name of your migration. In our case, you could say we are initializing the schema. You could say init to do schema, whatever name you want to give to this migration, and run this command. What will this command do? It'll say, okay, user has been added, to do has been added. Let me generate these SQL queries for it. So that is what will happen when you run npx prisma migrate dev. Once you do this, as you can see, the call out here says, check the prisma/migrations folder. Okay. This did not exist before. Before we only had prisma/schema.prisma. Now we have prisma/migrations. And if I open the first folder over here, what is it called? It's called migrations/ a timestamp _ init to do schema. The same thing I gave here when I was running the command init to do schema. If you remember, oopsie daisy, this was the command that I ran, npx prisma migrate, and I gave it a name. The same name appears here finally in this folder, and it has a migration.sql. Can you guess what this SQL file contains? As you can see, it contains my create table queries. So Prisma generated, given this schema, it generated my migrations for me. It put them at a top level folder. So I don't have to worry about writing all of this ugly code. I just have to worry about writing this, and Prisma takes care of creating the final migration files for me. If you look at them, they look pretty similar to the code that's written here. Only, primary key was present here separately. Here we add a constraint later on. But other than that, this and this are exactly the same. ID is serial. ID is serial. ID was primary key here. We define ID as primary key at the bottom. Cool. So what have we done until now? I initialized Prisma. What was the command that I ran to initialize Prisma? npx Prisma init. I started a database locally. What was the command that I ran to start the database? It was docker run this specific command to start the database locally. I replaced my database URL here, and then I added my schema over here, and then I ran npx Prisma migrate dev to actually create the migrations, to actually create these files. Harkirat, do you mean okay, now if I change the schema, let's say I add email as a field over here, how will I regenerate the migration.sql, Harkirat? You added it here. I don't see it in the migrations folder. How does it get re-added? Great question. As I said, anytime you update schema.migration, you have to rerun migrate dev. You have to tell Prisma to regenerate or generate the changes that have been made, not regenerate. Big difference between regenerating and generating the diff. Prisma is no longer going to override this file. Prisma will not be like, acha, you added email here, let me add an email field here. No. What it will do is, it will create another file. Let's see what it does. Let me run Prisma migrate dev again with the name added underscore email. If I run this, you will see migrations now has two folders. It has the init folder that was already there, and it has the added underscore email folder. If I expand this, you'll see that's what it says, added underscore email. And if I look at the migration here, what does it say? It says alter table user, add column email, and then creates an index on it, which is something that Prisma does. Ignore that for now. This part, hopefully you understand. As your application grows, as you change your schema, Prisma is keeping track of all the changes and generating migrations for you. Since you have all of these migrations in a single place, it's very easy for you to move from Google Cloud over to AWS, over to someplace else, because at least the schema you have in a single place. Harkirat, will all the data be here as well? If I add more users in my table, will they come here as well? No. The data will only exist in your tables. The schema you have over here. Hopefully that's clear. All right. So we're slowly beginning to make our application. I've added some schema in here. I have not yet related data together, but I've at least started to create the version of a simple full stack to-do application. Let's look at what the next slide asks us to do. It says, explore your schema. You ran migrate dev. This not just created these migration files, but also applied them to your database. So let's check out our database. Let me expand this a bit. And if you remember from yesterday's class, 12.4, the way to run PSQL on your database, the way to actually interact with your database from a CLI was this. And if you don't understand this, you should go through the class from yesterday, 12.3 or 12.4, the class called actionable Docker. If I go here and if I run the command -h localhost -u postgres -d, there you go. I can interact with my database. If you don't understand how I was able to reach the PSQL shell and what even is PSQL, then you should go to the video titled actionable Docker. Now if I run /dt exclamation over here, which is what the slide asks me to do as well, you will see I can explore my database. I can see a to-do table was created and a user table was created, which means when I ran the command that I just ran, which was migrate dev, it not only created these files, it also applied these changes on my database. It actually created the user table. It actually created the to-do table. That's the benefit of Prisma. It's generating these files also, it's applying them also. If I ever change my database in the future, I can reapply all of these changes over there by running the same command. All right. So we have a database, we have migrated the database, we have our schema, we're good to go. We can write the application logic next. So the next thing is, how can you actually start to write code in source/index.ts that can talk to your database? How can I create an express application here, Kirath? App dot how can I write app.get /user user.find where whatever id is rec.user.id. How can I start to write this code now? Where does user come from? Is there a Mongoose library? Is there a PG library? Or is there someplace else where I can get this user from and I can start to do a user.find or to-do.find, so on and so forth. So here comes the concept of auto-generated clients. If you remember the syllabus, auto-generated clients was a part of the syllabus. It was meant in a different context here, but even Prisma lets you auto-generate clients. The first thing to understand is, what is a client, Harkirat? And client is nothing but this to-do. A to-do, a user object, a to-do object, anything that lets you interact with the database is a database client. It is letting you talk to the database, and hence it is called a client. Question is, how do I generate this client, Harkirat? Given I have schema.prisma, given I have the shape of my data, how can I generate a class called to-do where a find function exists that I can simply call over here and pass in, where id equal to something, or do a to-do.insert, or do a to-do.get, or to-do.update, so on and so forth. If you remember, go back to YORMs, this is what I shared, right? This is how we used to write code. This is how we will write code now. Question is, where does user come from? How does this client get generated? And the answer is again one command that you have to run, which is npx prisma generate. If I copy this command and run it here, you will see it says generated Prisma client to /node modules @ Prisma /client. It generated some files for me here. If I go to node modules @ Prisma /client, this was just generated for me. This, if I start to explore the code over here, is when I will find, a user that is exported, a to-do that is exported. And now I can start to use it in my application. I repeat, the @Prisma /client was just generated when I ran this command. It clearly logged it here. Generated Prisma client to /node modules @ Prisma /client. Now I can use this client in my index.ts over here and start to, talk to my database. So what did we learn? We learned that Prisma doesn't only give you migrations, it also gives you a client that you can use in our application. That is exactly what we're going to do next. We're going to import Prisma client from @Prisma /client, from where the client was generated. Where was it generated? /node modules @ Prisma /client. This is where the client was generated. This is where a bunch of files were put, which I can now use directly in my code base. Initialize a Prisma client, and now see the magic of auto generation, autocomplete. If I write prisma.u, it shows me user exists as an object here. What does it say? Property Prisma client, whatever user. If I write .find, it shows me a find first function is present, a find many function is present, a find unique function is present, which means I, as the application developer, only wrote this, and then all the magic to write the final SQL query. If I run prisma.user.find, what is happening? This is in the end getting converted into such a query, right? Select star from user where ID equal to 1. In the end, if I write some code like this, it'll get converted to an SQL query like this. But who has written all of this code to convert this function call into this? Prisma client. All of that code exists here. I don't have to worry at all about, writing SQL queries. The Prisma client does it for me. And if I was not using SQL, if I was using MongoDB, then this find many function would have the logic to connect to a MongoDB database. This is the benefit of Prisma. Okay, this code remains the same. Doesn't matter if you're using Mongo or whatever, Prisma will generate the respective client. And then in your application, you just have to call this function. You don't have to worry about SQL queries. Cool. Now let's write this function which it asks us to write, which is an insert user function that takes a username, password, first name, last name as an input and actually puts them in the database. Thankfully, Prisma gives us very nice types. So I can simply start to, explore .user.create. This probably means, okay, this lets me create data. Another thing it was showing was create many. This probably lets me put multiple entries in the same function call. So you can just start to explore the syntax for this and, types for this. If I go here, the ideal way to do this is, okay, go here and then figure out what are these arguments, then reach here. Acha, there is something called data over here. That probably means that I need to pass in this is how I pass in the data to the function call. So if you want, you can really explore this and, reach the types correctly, or, just go to Prisma, how to create, then search and it will give you the way to insert data. Prisma insert data. CRUD reference. So you can just read from it here. Create function call requires a data in which you pass email, password, whatever you want to. Or if you want, you can explore the types over here and figure it out. Either works. In my case, I'm just going to, go with the flow here. Data requires what? Username, password, first name, last name, email, which was another thing I added. Let me pass in email here as well. And you're good to go. This is the code that I had to write. Let me just full screen it. To create an insert user function that does what? Prisma.user.create and passes in the data. If I call insert user over here with, some random fields, and if I start this TypeScript project or, start the application, how do I do that? tsc-b node.dis/index.js. You will see now if I explore my database, let's see, let me again do a docker exec followed by a psql followed by a select star from users or user, whatever the table is. You will see it has 0 rows, which means this creation over here failed. Let's see why. Let's log this. Let's do a const response equal to await this thing. And then let's do a console.log of response. So we can actually see if did this query fail, and if it failed, why did it fail? Why do I feel it failed? Because when I'm doing a select star from user, it is showing me no users, even though I think I've called the insert user function, but seems like it did not happen. So let me open another terminal. In this terminal, run tsc-b and then do a node dis/index.js and see what the log says. It says a user has been created with ID 1, username test, password test, so on and so forth. Let me add another user and then try that one more time. It says a user has been created with ID 2, so on and so forth. If I run select start from user, it shows me 2 users. I don't know what. I'm sure if you can go back to the video and figure out what I did wrong. But now, as you can see, as I'm running node dis/index.js, it is able to put data in my Postgres database. And did I have to worry about SQL queries? No, I don't even know what an SQL query is. I just know prisma.user.create, pass in the data that I want to put in, and good to go. I don't worry about SQL queries. So that's the benefit of using Prisma. Small assignment. What do you think will happen if I run this again? Can you guess? Will a third user be created or something else will happen? It threw an error. Can you guess why? Because we said a user will have a unique username. So I cannot resend another user with the same username. I'll have to change this value a bit. And then if I run it again, it'll let me put the, email is also unique. So let's make email unique also. And then let's try that one more time. And a new user has been created. Cool. That is how you can bring Prisma into a simple project. Everything else is fine here. We have a simple project. We have used Prisma to actually initialize it. You can, create it yourself by, copying all of this code here if you want, or writing it yourself. The solution is present here. So if you go through the steps, you can actually, copy the solution and try it locally. Or if you want to code it yourself, I would urge you to do that. And then standard, how to update a user, how to get a user details, how to delete a user remains pretty much the same. If you want to update a user, it'll be, prisma.user.update. And then, these you can figure out either by exploring the types or by going to the page that I had here and, going to the update section and checking, prisma.user.update is how you update a user, and so on and so forth. Cool. So Harkirat, this is done. This we had done during the live video as well. What is new? And the new thing is the next section called relationships. If you remember, when I had created relationships in SQL, so this is the SQL track on daily code. And here when we created relationships, I had a foreign key constraint. I said, bhai, if there is an addresses entry, there will be a foreign key to a user. There will exist a user that has this specific address. And similarly, we should probably add a foreign key here, right? If you remember the schema, this is what our schema looked like. A users and a to-dos model. This is not yet related to this. But Harkira, there is a user ID here. It is related. Yes, but I haven't enforced the constraint. I haven't enforced if there is a to-do, there needs to be a corresponding user. That does happen when you add a foreign key. When you add a foreign key, you cannot put in an address unless a user exists. Similarly, how can I add a similar constraint here? How can I create relationships or enforce relationships in Prisma? And the answer is Prisma gives you something very similar, very simple to do it. There are many types of relationships. One-to-one, one-to-many, many-to-one, many-to-many. Pretty self-explanatory. If there is a to-do application, this is a one-to-many relationship. One user has many to-dos. Harkirat, what is a good example of a many-to-many relationship? Good question. Let me think of one. Many-to-many. Oh God, I can't think of one. All right. I had to Google a bit and think of a good example here. The best example I could find is if you have a use case where you're storing books and authors, let's say you're creating an online library, then a single book can be written by multiple authors, and a single author can have multiple books. For example, the Harry Potter book is written by J.K. Rowling. The 5-point-someone book is written by Chetan Bhagat. But let's say there's a third book called Hindi Hari. This has been written by both of them, Chetan Bhagat also and J.K. Rowling also. This is a many-to-many relationship. Okay, J.K. Rowling has 2 books and this book has 2 authors. When both the sides can have multiple entries, if a single row here can have multiple relationships on the other side and a single row here can have multiple relations on the other side, is what's called a many-to-many relationship. Usually until now, we've only seen one-to-many relationships. One user can have multiple to-dos, but a single to-do cannot have multiple users. So that's why we are more comfortable with one-to-many relationships until now. But a very common use case is many-to-many relationships. And if you ever want to store them in your database, in a SQL database, I repeat, forget about relationships for a moment, forget about Prisma for a moment. If you have a simple Postgres database, if you have a simple SQL database, the way to store many-to-many relationships usually is have a third table that relates data from both of these tables. I repeat, have a third table called books underscore authors underscore mapping, which says by this book ID is related to this author ID. This book has been written by this author. And here you can have repeated rows. For example, here you can see the book number 3 has been written by author 1 and book number 3 has also been written by author 2. You have 2 entries for book number 3, and this is how you can maintain a relationship that's many to many, something that we hadn't really discussed until now. We should dive deeper into an application where we have many to many relationships. But if you want to try it out yourself, the way to create many to many relationships in SQL, forget Prisma for now, very easy to do it in Prisma. But let's say you had to do it yourself in SQL, then you would have a third table given your books and your authors table that lets you relate data together. Now, if I ask you, give me all the users for a specific, give me all the authors for a specific book, you can query this table and get their IDs. You will also have foreign key constraints here. Okay, book ID is a foreign key to book and author ID is a foreign key here. So you can actually create joins and get all the users, all the authors given a book or all the books given an author, which will be like common queries that will be asked, right? Cool. That's what many to many is, but we're thankfully not dealing with many to many today. We're dealing with a very simple one to many relationship, which is users on the left and to-dos on the right. We've already written it, but the only thing we hadn't written is how can you relate them together? How can you add foreign key constraints? How can you say, okay, by this to-do, you cannot put something over here unless there is a user. Unless there is a user that exists with ID 1, you cannot put an entry here with a user ID 1. And the way to do that is, in our original schema, you have to define both of these sides. I repeat, you have to define, okay, a user can have multiple to-dos. If I go back to schema.prisma, I can say a user can have multiple to-dos. It's so funny, it just knows. And a to-do already has a user ID, but we also say, okay, this to-do will refer to the users table. It will have a user field. Now again, this does not reach the database. This is just a logical representation here. Okay, every user will have multiple to-dos. Could be 0, could be 100. Every to-do will have a relationship to users. The syntax is user is the field name, capital USER represents the model, and then at relation is the new thing to learn. Okay, there is a relation between the user ID field over here and the ID field of the users table. That's how you are relating data together. If this feels weird, let's create a migration. Let's run npx prisma migrate and give it a name, call it added relationship. What do you think should happen? What do you think the migration that has been created will contain? Can you guess? The migration that has just been created, the third one, will contain what? It contains add a constraint, this thing, foreign key, user ID references user ID. So it added the foreign key constraint. It did not add anything to the users table. It did not add a new to-dos array to the users table. It did not add any new users field to the to-dos table. What did it add? It added a foreign key constraint. So even though you're writing a lot of things here, not everything from here is reaching the database. It's not like it added a new field in the users table called to-dos. It did not do, an alter table to user add column, to-dos text array. It did not do this. Just because you're writing to-dos is an array of to-dos doesn't mean it is reaching your database. It's simply saying, I've added a constraint in SQL, in Prisma. You're just telling these two are related to each other. And in case of SQL, that simply means adding a foreign key constraint. So you don't have to worry too much about, my God, my database schema became so complicated. No, very simple. It's exactly the same from the SQL slides. We had this. The only thing we did not have was this. And now, after I've added the constraints, I see a migration which has this as well. So the foreign key constraint has also been added. Everything else is the same. There's nothing new that you've sort of done here. You've just added a constraint to make sure the to-do table, which is this table right here can only have an entry given a user exists. You've added a foreign key constraint over here. Only you don't need to know the syntax of how to add it. You simply said, bro, I'm going to go to schema.prisma. I'm going to add this. I'm going to add this. And then Prisma figures out that they are using SQL. So I need to add a foreign key constraint. This file was auto-generated. Cool. Great. What's the next step? Let's see what the slides say. The slides say, okay, now regenerate the client. You added a foreign key constraint. So just how you've created the migrations again, maybe regenerate the client. Maybe the client changes a bit also. So let's do that. npx prisma generate was the command to run to regenerate the client, to regenerate what exists in ./node modules / @prisma / client. So now if I go to index.ts and initialize a Prisma client, now I can do some extra things. Let's see what those extra things are. Let's say I ask you to ignore the create to do, even though you can use this, that's fine. But the get to do function is going to be interesting. I ask you to create a function called get to dos, which gives you all the to dos given a user ID. So it looks something like this. Given a user ID, give me all their to dos. What will you do? You might be like, Harkirat, I will do prisma dot to dos dot find many, where user ID is this user ID. This is what I will do, Harkirat. I will await on this, and then I will do whatever return response, or I will do a console.log response. This is right. That's exactly what you had to do. And the thing that we just added, the constraints that we just added in schema.prisma, this right here, adding these gave you no benefit. This you could do without those constraints as well. So there's nothing special that these constraints gave you. You could have totally just done const response equal to this thing before as well, and it would have still worked. The thing that the constraints provide you is that you can now start to relate data together, start to join data together. Let's say this is simple. Let's run this also. Let's make sure it works. We have no to dos in our to dos table, which means this should just return 0 or null. So let's run tsc-b, and then let's do a node dist/index.js, and it returns me an empty array because there is no to do right now in our to dos table. It's completely empty. Let's say I ask you get to dos and user details. I say, okay, bhai, I want all the to dos for this user. I also want their details. I want their first name, last name, email, so on and so forth. How would you do this? Would you create two queries? You would be like, okay, Harkirat, I will get all the to dos from here, and then I will do another user details equal to prisma.user.find, where user ID equal to this. You can do this. Or what can you do? If you remember from our last session, we introduced joins in the end. And even though Prisma doesn't do joins, it will most probably do subqueries. Either way, you can get both of these details in a single command, given that data is related. You already know, okay, by to dos is related to users, users is related to to dos. And so you can select not just, let's say, the ID of a to do and the title of the to do. You can also select all the details of a user. Okay, bhai, I want the ID of the to do, I want the title of the to do, I want the description of the to do, and I want all the details of this user in the single query. If I run this, it will give me an empty array. So let me add something to the to dos table. Let me comment this, and let's do a await prisma dot to do dot create data, title, description, and user ID 1. Let me add some data to the to dos table. So I'm just running this dummy command to create a dummy to do. Sorry about that, too many windows. Hopefully this to do has been created. Let me revert the code and see if I now get back not just the to-dos, but also the user details along. Why was I able to do this? Because Prisma knows that they have been related, that every to-do has a corresponding user. I would have not been able to do this if I did not had the relationship. Only because I've added a relationship does Prisma know that every to-do has a user, and hence I can use user true over here and get the details of the user along with the to-do. If I run this, now it gives me ID, title, description, and all the details of the user in the single query rather than me having to run two different queries. Now, this doesn't necessarily mean this is the most optimal thing. This might feel a little unoptimal actually. If a user has 100 to-dos, then you have 100 rows with title, description, and repeated users. So I'm not saying this is the right thing to do in this case. Two queries might be a better thing. You can do something else. But now at least in a single query, you can fetch not just the ID, title, description, but also the user. So what was the benefit of us adding a relationship constraint over here? Number one, now you cannot add a to-do unless a user exists with that ID. So I cannot just, if you remember, I just inserted some data. Let me try to insert it with a random user ID. Okay? Yeah, this is a good example to run. Let me say I will insert a to-do for a user with ID 100. And this user doesn't even exist. If I now try to run this code, it gives me an error. It says foreign key constraint violation on the field. This thing, basically the foreign key has been violated. There is no user that exists with an ID 100. There is no foreign key that you can create from here, which is why this is problematic. And that's the benefit of creating these relationships. If I did not have these relationships, if I did not have this and this, then I would have it wouldn't have complained. This query would have just run. So that is why adding constraints is super helpful, so that you don't have runtime errors, so that as your developers write ugly code by mistake, your database doesn't get polluted. Your database does not have any orphan values here. And what do I mean by orphan values? Any values that exist here that don't have a corresponding user over here. Cool. That's how you create relationships in Prisma. And this is a simple create to do for you to like test things out. And lastly, there was an application here that you can try out if you want to create an end-to-end application in Express. So you can expressify the to-do application. Basically, I had no Express routes here. I had like a very basic function, but you can create an Express app on top and have a simple to-do application run. That's easy. The hard bit is, how do you bring Prisma in a worker environment? If you remember what's a worker environment, if you remember this specific slide on serverless backends, how do you bring Prisma in serverless backends is a good question. How can you make use of something called connection pools, which is something we will discuss in the next video. Cool. For this video, I would urge you to practice a bit, at least write all of this code and, try to expressify the whole application. Shouldn't take you, if you understand this, it shouldn't take you it shouldn't take you more than 5 hours to, build an Express application which uses Prisma, has constraints, and lets you, put to-dos, get to-dos, so on and so forth. With that, let's end it. See you guys in the next one. Bye-bye.